Morning, good evening to everybody, depending on which part of the world you're logging in from. We will be talking about API security for cloud native applications in this session. So this is our agenda for the next 45 minutes. We'll start with a brief introduction of myself and then zoom into the different aspects around API security and why distributed tracing, a technology which started off in observability and APM, is relevant in API security, and how you can actually solve the different threats and vulnerabilities that you see in the API based applications with distributed tracing. So we'll talk about that in detail. Then we will start with looking at Traceable. The platform, what are all the different ways by which you can secure your applications using Traceable, and then look at some of the top 10 OWASP API threats and how they can be addressed with the Traceable platform. We will end with a demo where we will actually demonstrate how all the different threats that you see in this landscape can be addressed within Traceable. And we also have a very interesting contest for all the API Days Paris participants to actually get a hands-on experience with Traceable and understand how the API-specific threats can actually be addressed using Traceable, and how you have all the capabilities to protect your applications and APIs with this technology. So that's our agenda for the day. Let's jump right in. So I'll start with a brief introduction of myself. My name is Sudeep Padiyar. I've been in the industry for 15 plus years now. Been in product and engineering leadership roles. Started off in Cisco, working on a lot of the core routing and switching technologies, which are enabling, the internet backbone as well as data center switching and routing. Then moved into security at Palo Alto Networks close to 7+ years ago. And I've been in security, in cybersecurity, cloud native security since then. I joined Traceable earlier in the year, seeing all the different potential capabilities that we can bring in for API security and solve this problem elegantly as the world moves towards software and moves towards APIs. So that's what I do at the company. Been looking at all the different aspects of the product and how we can secure your APIs better with the interesting technologies that we build at Traceable. My personal journey in my professional life, I started off with core routing and switching, wherein a lot of the data center architectures were actually being built using physical switches. And then we saw that transition into network virtualization, and then what came to be known as software-defined networking, or SDN. And that actually saw this disaggregation of hardware-based networking products into software switches, whether it was on VMware or Microsoft Azure or Hyper-V, and then moving into the public cloud with the virtual private cloud from AWS or Azure and Google. I see something very similar happening on the security side with the disaggregation of the applications and move into microservices. And the implications for security is what really gets me excited about this job, as the applications are being broken down into microservices from the monolith. What is the true implication for security, right? As in, if everything is API based and that's the direction that we are going in, then what are the actual threats which are going to be relevant? And I see that being very similar to the disaggregation that we saw in the networking world. So it's a very interesting time where you see a lot of these changing technologies having a lot of implications on security, and it becomes important to take an approach from the ground up to solve this problem elegantly. So let me jump right into why distributed tracing, why we picked this approach, and why does it actually give you a very holistic approach to tackling API security in a very different way. So let's start by looking at what is the primary difference in an API-driven application and what are the implications for security with this approach. So we all know in the last 3 to 5 years, with the advent of containers, with Kubernetes, with microservices, there has been an approach where you are breaking down your monolithic applications into different services, and you are actually accessing them using single page applications instead of the approaches that you were using earlier with a traditional web-based client. So what is the change that this brings for security is becoming very interesting. So the developers who are actually building these microservices and these applications are very well versed with the APIs that are part of their application, right? As in, if they're developing a backend which is connecting into Mongo or Redis or into a AWS native service and rendering some information for the front end, then they are very well aware of what those APIs entail, what is the authentication around it, how are they authorized, and they have a very good understanding of that. On the other end of the spectrum, you have the security team for which a lot of these components are a black box. What they are aware of is that there are a bunch of applications which are now being released to meet a certain business goal, but they really do not understand that what are all the different threat vectors or vulnerabilities that these APIs will expose when they actually go into production, right? So they have a very superficial understanding based on either what the documentation explains or how they profile some of these applications when they make it into production, right? So you will have a typical pen testing phase where a lot of these components are treated as a black box without actually getting an understanding of what are all the different APIs which are being released, what are the vulnerabilities in them, and if these are actually internet facing, then what are the potential breaches that can happen when these APIs are exposed to the public internet. So if you look at this picture that you see here, it's actually a graph which was obtained using Traceable, where you can see all the different services and how they actually interact with each other. So like the picture says, it's a pretty complex interaction between the different APIs, and you really need a way by which you can get a view of this all through the application development before it gets into production, as well as once it is in production, your security analysts and the InfoSec teams need to be able to understand the data flow between these different endpoints and what is the security implication if there is a breach or if somebody is actually trying to pull out data from some of these API endpoints when they do not have the legitimate access for it. So that is why we came up with using the distributed tracing approach, because with distributed tracing, you can actually have a very good view of all the different API requests and responses which are going between each of these APIs, right? So this graph that you're looking at is actually been built based on the tracing being enabled at these different points within your application stack. So the nodes are actually APIs in this picture, and all the interaction which happens when a particular application is accessed by an end user or by a machine or by a bot is actually tracked over real time, and we can understand the security implications here. So now let's look at some of the ways by which these applications are actually built and accessed by users, right? So if you take a typical mobile application for a ride-sharing application, such as an Uber or a Lyft, you will see that a lot of the actions that the users do using their mobile phones are actually events or specific things that they want to achieve from the application, right? They might want to see what are all the different locations where the automobiles are at that point in time, or they will want to send a receipt to another application which is used for expenses, right? So now all of these actions are being done from the mobile phone, but on the back end, they are reaching a bunch of different edge APIs, which then go into internal APIs and the external service, which is actually pulling a lot of this data, right? Whether it's coming from a database or it's coming from S3, or it's actually using another bunch of APIs from other third parties or other SaaS applications to bring and render this information, right? So there is a intricate means of communication of data between the different APIs to actually render a simple action that a user has done on the mobile phone. So what this actually means from an end-to-end view is that your user behavior is what is actually initiating the entire flow. But what becomes important from a security perspective is this a legitimate user, right? Is he or she accessing legitimate endpoints and doing the right tasks which are based on the authorization that the user has for those particular events or actions that they're doing on the website? So the first key thing becomes the identity, right? As in, if I am a writer of the application, then which are the endpoints that I legitimately have access to? And if I'm accessing some which I don't have access to, then what is the behavior, right? Ideally, we should not be sending any of that information if I don't have the right privileges, but we do see those kind of breaches happening all the time. So the user behavior is what forms the basic tenet for API security, because that is the mechanism by which you have to determine the right access controls. And if there is a breach because you are escalating privileges or you are accessing objects or other parts of the application which you don't have legitimate access for, then how do you actually alert and block those become important for APIs. The second aspect is around API activities. So like I was saying earlier, with microservices, you now have a distributed set of services which are instrumental in different parts of your application working correctly. So how are these internal APIs communicating with each other, or how are the edge APIs communicating with the internal APIs, and what kind of data is flowing between them becomes important. Around the sequencing, if you have a legitimate access by a user, then you will see a certain sequence of APIs being invoked with certain data wherein the user actually is the owner of that data. So that is your regular baseline on which you can then build models so that if there is an aberration or an anomaly, then you can start detecting those. So the sequence of API calls becomes very important. And for any security product, that is the baseline on which you operate. Now, a lot of the breaches that you see in this area are related to sensitive data, such as credit card information or PII information being leaked for hundreds of thousands of users, as we've seen with different organizations in the last 2 to 3 years. So the data flow, are you giving access to users for sensitive data which they should not be having access for, or are you giving additional information which should not have been surfaced in the first place? All of this become important, especially when they are reaching external services, because that means that any user on the internet who has an account or who's actually trying to take over accounts of legitimate users will be able to get access to that information. The last aspect is around code execution, and this is where all the different API parameters, how is the request and response data flowing between these APIs, has to be understood by the security products, and any anomaly or any breach around that needs to be addressed right away. So if you look at most of the security products in this space, you will see that the emphasis has been around the edge. And the context that you're missing is actually around the internal APIs and the backends, whether they are going to external services and APIs coming from third party, or they are going to a data store in the public cloud, or to other databases internally in your data center. how does all of that data actually go between the different APIs, even before it hits the edge APIs, is the context that is needed to actually piece this entire flow from a security standpoint. So let's start looking at how that can be done. So I'll spend a few minutes on the traceable platform, and then we'll start looking at some of the threats that can actually be effectively addressed with traceable. So the three basic tenets on which the traceable platform has been built has been around visibility, protection, and analytics. So like the age-old saying goes, you cannot protect what you cannot see. So the first aspect that you will see in the product is around an API catalog, which gives you a view of all the different APIs which are part of that particular application and which are actually running in either on-prem in your data center or in the public cloud in different environments, whether it be Kubernetes, whether it be front-ended with a API gateway or with a load balancer. So you don't actually have to understand this from your API spec. At runtime, we can actually pull all of that information so that what you see is actually the different interactions between the APIs at runtime. And we continuously discover the APIs. So that is the capabilities that we get in with distributed tracing, wherein if your developers are adding 20 new APIs or modifying APIs as part of their releases, then we actually are able to give you a comprehensive view of what are the APIs which changed and what is the risk associated with that, both from a vulnerability perspective as well as from a runtime threat perspective. When you do the right pen tests around those applications, we can actually give you a view of how your attack vectors have changed as you go between the different releases. On the protection side, you can protect both your web-based applications or APIs, depending on how they are being used for that particular application. And you can then start getting a holistic view around what are the different threats, whether they are OWASP API top 10 or whether they are OWASP top 10 or other common threats that you see in the web application landscape. So it's a combination of what you could have addressed with a WAF and a RASP in the past, with a specific emphasis on APIs. Now, because we are we use machine learning heavily, you don't need to build a lot of static rules at the get-go. But if you are actually migrating from a traditional WAF and you have a bunch of rules, then you can continue to leverage them. So we give you an option of starting with your rules and then moving into the machine learning based protection that we can provide. That actually helps us in causing lower false positives and ensuring that over a period of time, as we understand the API and application behavior, we can look for anomalies and flag them or block them depending on how you choose to deal with those kind of behaviors. The third aspect is around analytics. As we have data lake with a lot of this information around individual threats, around some of the vulnerabilities that we see over a period of time, as well as the sensitive data flow, which is a very important aspect around API security. You can actually start doing threat hunting to see that what kind of data was accessed by different kind of users, what is their profile, are they legitimately accessing this information? And as we see with data breaches, some of these happen over months. So the ability to actually do threat hunting effectively based on users, based on APIs, based on the data they're accessing, becomes very important. On the compliance side, because we have a very comprehensive view of the data and whether it's related to PCI or PII or HIPAA and others, you can actually get a very good understanding of if you are not being compliant with any of these regimes by looking at the data flow, and especially if they're accessed externally or if they don't have the right protection that is needed for compliance, then that can be flagged. All of this, like I said earlier, is built on top of our distributed tracing platform by using machine learning on the SaaS platform that is being used to manage this entire infrastructure. So let's zoom into the threats, and we'll start with the OWASP top 10 for APIs. Our chief researcher is actually one of the authors for the OWASP API top 10. So this has always been an emphasis for us within the company, and we strive to have extensive coverage for all the different threats that you see here, as well as for others which are relevant in this space. So I'll start with the broken object level authorization, which used to be called IDOR in the past, and what are the implications of this, as well as how do attackers typically breach APIs using this mechanism. So if you take your typical ride-sharing app and you see that most of them have a way by which you can rate the drivers for that specific ride that you had. So over a period of time, you will see that you are actually, as you do multiple rides, you are continuously using that particular functionality in the application. But what is actually happening on the back end is there is a need by which you can actually access the right trip ID, and you are typically using an identifier for that. In this example, it happens to be 718492, and based on that, you are actually able to provide rating for the different rides that you had on that particular ride-sharing app. Now, if you look at the way this request is structured, everything is hinging on that particular ID. And a very common way by which attackers can abuse this is by actually calling this for a multiple set of trip IDs. Some of them they did not even take, right? So because these are numerical IDs, you can actually write a script which will iterate through hundreds of thousands of such trip IDs, and then you can actually give them a rating of 0, and which will actually cause issues for the business logic of the application, and which will potentially affect that driver or potentially impact that particular ride-sharing app itself, because the ratings have now been abused. So this is a very common way by which you see a broken object level authorization being used by attackers. And this is just one example, but essentially you are giving access to a particular user for parts of the application which they don't have legitimate access for, right? So you need a way by which you can look at who is the owner for that particular part of the data that you're manipulating, and you need to ensure that they have the right authorization when they're accessing the different objects, right? So this is the most common attack that you see with APIs, and it's very important to address that. Another example of this, and this is actually a real-world example found by Anand Prakash from AppSecure, and this was Uber, right? So as you can see, a company which has, a large number of InfoSec as well as product security engineers. And if you see, again, another variant of broken object level authorization was used here, in this case with regards to the user UUID. And these are, again, a bunch of alphanumeric strings, and based on the different requests that you send for that user ID, the response would give you all the details around that particular user, including their PII information, such as first name, their last name, the country where they reside in, and all of this can then be used in other breaches because you have the PII information associated with that particular individual. So these are known attacks which have happened, with broken level object authorization, and it's extremely important to protect against this. I won't be going through all of them. The other one that I will pick is my favorite. As over a period of time, you've seen what started off as a programming practice has now been abused by attackers. So if you look at the distributed nature of your application, you have a very clear demarcation between the front ends and the back ends. So once that particular backend is processing the request, you are going to return a whole bunch of data via JSON. And what has happened as a result of the API economy and REST plus JSON is you have very generic endpoints, right? So your backend developer might think, hey, for this particular request, the person developing the front end is potentially going to need a whole bunch of information. So instead of us trying to deliver it in different phases, why not provide all of that information up front and then have the front end developer pick the pieces which are needed for servicing that particular request. And that is basically causing this issue where you have a whole bunch of data which is being sent in the requests, and anybody who is accessing that APIs now has access to that data. And in many a case, it could be PII or PCI information, which is then going to result in data breaches, because any API abuse that is going to happen on any of those endpoints will result in a lot of this data being available to the attacker. So another real world example happening with a bunch of dating apps that you might have seen in the recent past. So in this particular scenario, the user is logging in, and the front end needs to get basic information about that particular user to render all the details about him or her. And as a result of that query, you will see that the name and hobbies and other data, including the profile picture, is rightfully returned, because you need to render that information when somebody is looking at that particular profile. But what you don't realize is that as part of this request, the address is also being returned, right? And that's not something which is going to be rendered on the UI, but potentially the developer thought that there might be scenarios where the front-end developers might need the address, or inadvertently, because there are a bunch of different backend APIs which were developed, and this data is being expected to be sent to an internal service, but it got sent back as part of this response. So now, if you look at this, if you start using this API and you start enumerating on the different user IDs, then you potentially have another scenario where the sensitive information for a bunch of users for that particular dating application is now going to be available to malicious users. So these are two examples of the OWASP API top 10, and how different security products in this space need to address them becomes extremely important. So having said that, I will go into the different aspects of Traceable and how we address this within the product. So I'll start with a simple example of a Kubernetes deployment, and we support a whole bunch of environments, whether it is Kubernetes or things running in virtual machines with different API gateways, proxies, load balancers. So this is an example, but this can be easily extended to the other environments as well. So in this case, you have an application which is written in Java and Python. You could potentially have other pods which are running different languages such as Golang or Node. So in this particular scenario, if you have a load balancer at the very front, whether it is Nginx or an AWS load balancer, or you could have an API gateway. So in all of those scenarios, we'll have the relevant plugins from Traceable, which we call as tracing agents. So you can either run them in inline mode or in the mirroring mode. So we do support VPC mirroring in a bunch of the public cloud environments. So in case customers are not very keen on having the data, inline data being processed for the API security, then we'll allow you to do that out of band. So that's another way by which you can insert Traceable in a very non-intrusive way. So these the language agents that you see for Java or Node, you can have them in-app, or you can run them as a sidecar in Kubernetes, because that gives you another way by which, with very minimal friction, you can start looking at all the different traffic patterns between the applications. So all of this data, which is collected by the tracing agents, then goes into a platform agent, which is running in your particular environment. So that can do aggregation for all of this data coming in, as well as redacting if there is information about with privacy that we do not want to the SaaS sent to the SaaS platform, then that can actually be redacted or obfuscated at the platform agent itself. And similarly, as the the backend SaaS platform makes determinations about security and the rules and any anomalous behavior which either has to be alerted or blocked, then that information is relayed back using the platform agent as well. So as you see, we have a architecture by which you can take care of your data privacy concerns and ensure that any data which you do not want to leave your environment will stay within the environment, and then all the processing happens on the SaaS platform, and the decisions which are made based on the different machine learning as well as rule-based approaches are then reflected back into the right tracing agents. So this is the high-level architecture. Regardless of whether your applications are deployed in public or private cloud, you have a very consistent way by which you can secure them. So the different, to summarize the capabilities that you have with the different instrumentation options, if you use a mirroring or a gateway, whether it's an API gateway or a load balancer, you can protect and analyze all your external APIs, because the spans and traces that we will have access to will actually emanate from the edge in this case. So you can get all the protection for the external APIs. If you instrument all the way within your application stack with a service mesh or a Kubernetes sidecar or in-app, you can now protect and analyze your internal APIs. So again, that is the missing piece of the puzzle, which a lot of products miss, which becomes extremely important to understand the end-to-end application flow, as well as the impact that it has on security, especially when sensitive data is going through the APIs. And the third part around analytics, because we have an ability to be very close to the application with the in-app language agents that you saw earlier, we can do end-to-end tracing. You can do root cause analysis. You can look at some of the performance implications. If you have a volumetric based attack, then the way at which the responses are flowing back, what are the performance implications for that? All of that can be understood because we have the ability to actually be close to the in-app and understand all the implications there, as well as the user behavior aspects of it, right? As in, what is the baseline behavior for a bunch of users who have the same privileges? And if there is any anomaly for either, a particular users who are potentially, either abusing the system or who are attackers, then that baseline can be understood very easily by comparing that behavior with, the rest of the users in that particular group of users. And we can do that very elegantly because we collect this data right from the application. So to summarize, these are all the different environments in which Traceable is supported. All the way from the API gateways from Kong and MuleSoft and Ambassador, to the different in-app agents and the coverage that you get with that I covered, that I went over earlier, to traffic mirroring in VPC or Google or Azure. So all of these different options are available, and depending on the extent to which you want to get coverage and where you actually want to protect against API specific attacks, you can pick the right combination. Actually, customers who are interested in ensuring that there is comprehensive security end up picking multiple of them, whereas others who are focused on the edge, do go with the API gateways. So we give you this ability, and because we are based off distributed tracing, we can actually provide the mechanics for securing any of these environments in a comprehensive way, and we give customers a choice of picking one or more of them depending on their use cases and what they're trying to secure. So having gone through the different capabilities of the product, I will next zoom into an actual demo of how Traceable works. So this is the API intelligence dashboard. This is the first thing that you would see when you log into Traceable. Now, what you're seeing here is what Traceable has automatically uncovered with the different agents that I was talking about in the presentation. Now, in this case, you have an application running in Kubernetes, and we have the relevant in-app agents, which are providing this view of all the different APIs which are part of that application, right? So here we know that you have over 1,000 APIs, out of which 80 of them have been learned completely, and the others are still in learning. So the key aspect here is you can then look at all the different API endpoints based on recent activity, as well as what are the risk score or call volume associated with that, right? So if you look at a volumetric attack, or if you have a bunch of bots accessing your APIs, then your call volumes will be high. If there is any malicious activity around that, then you will see them appear in the threats, as well as the risk score will have to be taken into account to ensure that you are addressing security around APIs which have a higher risk score, right? So all of those can be obtained right at the very get-go with the API intelligence dashboard. And in this case, out of the 80 plus learned APIs, you have a very easy view to understand that 11 of them are risky. So from a developer standpoint, those are the ones that you will start focusing on. And especially depending on whether they are edge or internal, and if they are actually accessing sensitive data, then those are the ones that you would prioritize in terms of looking at and fixing the vulnerabilities in them. So the next key aspect is around the API and application flow itself. So if you look at the application flow, you will then see all the different services which are part of that application, right? Like I was referring to earlier, because we have a capability to be instrumented all the way from the Nginx load balancers to the backends, you will see that all of the different services which are part of that particular application and the data flow which is going between them. You will also see some of the latency aspects. So like I was explaining earlier, if you have a volumetric attack, then you will start seeing that that amount of time that it's taking for your services to actually respond back will increase exponentially, because you are facing a whole bunch of requests. And if those are actually coming in from a botnet or from malicious users or from certain scripts, then you can start taking the action accordingly. So if you start zooming into some of the individual services, you will start seeing some of this data around call counts, around errors, and that will give you the first view to understand the volume of the traffic which is going between these different services. So if you then start zooming into each of them, so I picked that particular data service, then you will start looking at the overall health of that particular service. You can look at the total number of calls. You can see the latency associated with that, as well as then start looking at all the different endpoints which are part of that particular service. So this way, you can actually start zooming into the overall application down to the individual endpoints, right? So these are the 4 endpoints which are part of the data service, and you see the corresponding risks associated with each of them, right? So if you look at the product ID API, for instance, this is the one which is going to return all the different details around the product. You will see here, what is the typical status codes which are received by that particular API. What is the diversity in terms of clients who are accessing that API. So this goes back to the internal versus external, as well as, what is the exposure that you have for this APIs with regards to the, set of IPs which are addressing them, right? As in, are they coming from a single geo? Are they coming from multiple geos, as well as, over a period of time, who are the kind of users who are accessing this endpoint is something that you can start surfacing. And then if you get into the DNA, this is where you will see all the details of the API spec, as well as you can start searching if you have any sensitive data associated with them, as well as looking at all the traces, which are part of that single endpoint, right? And this is the beauty of distributed tracing, because in a few clicks, you have gone from understanding the overall application flow into actually looking at the different aspects around the request and response, which are part of that particular endpoint, right? So in this case, you are looking at the spans which are associated with that. So you can look at the entry span ID. You can look at the URI, which was associated with that particular request, as well as all the data associated in the request and response, all the way down to the cookies. And then the attributes is what we will pick, and based on how we have seen that particular, data come in. So in this case, you know that it's coming from an environment which is production. That it's coming from a proxy and a bunch of other data which is associated, with that particular span is something that you can start using from a security observability standpoint. So going back to the API endpoints, the risk aspect is something which your developers as well as product security engineers can start zooming into. So in this case, the risk score is high for this particular API, and the reason for that is articulated at the very top, right? As in the likelihood of this being exploited, the exploit surface itself is high. The ease of access is high. So in all likelihood, as the name suggests, it's a cart checkout API. So it is exposed externally, and it has a bunch of sensitive data, which means that you need to have more protection around these APIs, right? So you will see here that you have street address associated with it, and you can also then start marking the sensitive data. And this will help as a developer. You can start marking this data so that that for your infosec and compliance teams, then they can start taking the relevant measures to ensure that these APIs are protected, with the right approach. So you also can look at all the factors which went into that particular risk score, and we also allow you to edit some of that, in the latest iteration of the product. So these are all the different aspects which are associated with the API endpoints. We've also allowed you to kind of manage the labels around this. If you want to tag them, that's an upcoming feature which will be part of Traceable, where you can, if these are coming from, if the spans are coming from certain applications and you want to start using them in your policies by using labels, that's another capability which is being introduced in the product. The other aspect is around vulnerabilities, right? So, and again, all of these are uncovered over runtime on, which are the endpoints which don't have the necessary encryption, that is needed So you will see them highlighted at the very get-go, and we also tell you the mitigation on how can you address this, whether it is by using the right encryption mechanism, by using TLS in this particular case, and you can also signify what is the action you are taking on each of them, right? So as a developer, you can indicate that you are these are still under review, or if these have been resolved, then the relevant status will indicate where how this has been addressed, and this is also something that you can use in the CI/CD pipelines to ensure that you will only allow the build to go through if a vulnerability of a certain severity has been addressed in that particular build, right? So all of those integrations are possible, by using the APIs that the product will support. So this is with regards to the vulnerabilities. Another key aspect is around the backends, right? Like I was explaining earlier, where is the data which is being used to service the different requests? Where is it coming from? What are the risks associated with that? If it's coming from an S3 bucket, or if it's which itself doesn't have the right security mechanisms around it. All of those become important as you start looking at the end-to-end data flow. So the backend information, again, in this case, it tells you that the data is coming from MySQL. But if it were coming from another set of third-party APIs or cloud services, then that can be used to understand the overall security posture as well. So those are all the different aspects within API intelligence. Next, I will actually look at a few attacks which you can, the OWASP API specific attacks which you can run against applications, and how the product actually detects that. So I'm actually using Postman, and we have a particular application which is being protected with Traceable. So it's called Trace Shop. You can also access that directly on the using the web URL. In this case, I'm actually accessing it using Postman. So this is the host, and for those of you who will participate in our contest for the next 1 week, do keep that in mind, that these are some of the configurations that are needed from ensuring that you are targeting the right application with these specific tests. So in this case, the specific application that we are protecting is called Trace Shop Playground. So if you go to this particular URL, you will also be able to access that application directly, right? So this is a typical shopping application, and we will explain how the different vulnerabilities are exploited using Postman, and how we can actually protect against that. So I'll start with an LFI attack. So that's the local file inclusion. These are all the different headers which are part of the request. And another key attribute that Traceable supports is what is called as user attribution, right? So depending on the relevant JWT tokens or the request headers, we can actually detect who are the users who are accessing those APIs. So we can do both the user anomaly as well as use that for the relevant blocking rules, as well as categorizing the attackers. So I'll be sending this request to that particular application. And now, because Traceable is actually protecting that, let's see how it shows up in the product and what is the relevant action we have taken. So if you look at the active attacks, this will show up under the active attacks. Now you have different levels of protection that you can use here. So in case of this particular attack, and I'll show you the setting in a bit, but we don't have a blocking rule for LFI, right? So this will show up in the active threats, and you can then start taking the relevant action. So in this case, the particular local file inclusion attack, like I was saying, you will also see the user attribution. If you see the request header, it had the information with regards to the user. So we have attributed that correctly. You see all the services and endpoints which are part of that request. And if you then go into the details around that particular attack, you will see the specific URI, you will see the associated spans, as well as what was detected with regards to the request headers and how we classified it as a path traversal attack, right? So all of the details which you need to diagnose, as well as take the necessary action in the code so that these can be prevented, is something that you will find in the details page as you go into all the different aspects around that attack, starting from the cookies to the response, because typically the pen testers are actually making these attacks. They will have all the details from a product security or infosec person standpoint, because all of this is captured within the product. You can start zooming into more details to do the relevant analysis, forensics, and threat hunting that I was referring to earlier, right? So these are the security events. Now, in cases like I'll go to the next attack, which is remote code execution. So again, I'll send that attack from Postman. Now here, if you see, you get the 403 error. And the reason for that is we have blocking rule for remote code execution, right? So this ensures that you will actually block that traffic and return a 403 error. And again, that is something that you will see under the blocked events. So because of that specific rule, you can now start seeing all the details around this specific attack, which endpoints were they seen on, as well as the relevant tracing information, right? So now this is what allows you to do all the forensic investigation as you start digging into, what was a specific request, who did it come from, what was the user agent involved. So all of these details will help you analyze as well as to take the necessary remediation path. Similarly, on the response side, you can start, digging through the data to understand all the details around the attack. So that was one aspect of the product where you can actually see the events. The other interesting aspect is the attacker, right? So in this case, because the user ID that I'm using here, which is Sudeep at API Sec, was involved in these attacks, you will see that the threat score has bumped up to 100, right? And you can start seeing all the different activities that that particular user has done in the course of the last couple of days here. And this will give you a view of all the different attacks, as well as you can now start taking the relevant action, right? So if you want to, now in this case, I'm using the playground aspect of the product. So this is just a way by which you can understand all the capabilities and you don't have the relevant access. But if I zoom into the application, and this is as simple to go from the playground where you can understand the different capabilities with an application that we are providing, to actually protecting your own application. So if I then go into my own application, then I have all the ability to take necessary action, right? So as in, if I want to suspend or deny access to this particular user, or I want to snooze them for a certain amount of time, all of the different capabilities are possible for users who have actually instrumented their own applications and are protecting them. So this is the overall API flow, the API sequencing that I was talking about earlier. So this actually gives you a very comprehensive view of, in case of this particular attack, excuse me, what were all the different APIs which were part of that flow, as well as which was a specific endpoint on which the breach actually occurred, right? And then you can start, zooming into details around the DNA, around the sensitive data, as well as all the events which were associated with that particular endpoint, right? So now you can start aggregating all the events which came in from that particular attacker, as well as from other attackers who are potentially compromising that endpoint. And if this is coming from a botnet or it's coming from an automated script, you will potentially have a bunch of different source IPs and user IDs which will be involved in these orchestrated attacks, right? So you can now correlate all the different events with that particular API endpoint right at the get-go. So this was the demo with regards to all the different capabilities of the product. I want to indicate that given given the relevance and importance of API security, we have a free product so that there should be no. We want to enable all the different users to be able to try the product and understand the implications of API security. We also have a special contest. All the details are here. We'll also send out those over email. Essentially, if you can explore the playground and send us a video of how you are actually accessing the product and how you are finding it useful. All the details are in this documentation. You can create your own self-service user ID, log into the product, explore the playground, go through all the different attacks that you will be able to uncover, understand the endpoints, the services, and then, for those who actually want to try attacks, there are further instructions. And a lot of it is what I went through earlier with regards to, using Postman to orchestrate attacks. We have a whole bunch of attacks that we allow you to, try on the sample application. And, if you decide to instrument your own applications, and you can create a similar version for your own app, and then start looking at all the different vulnerabilities within our application and how you need to start protecting them against real-world attacks, right? So all of the details are in this documentation. We really look forward to you trying our product, looking at all the different capabilities of your own applications. So this contest will be on for the next 1 week, and we also have a Slack channel where you can contact us if you have any questions, which are which will come up in when you start trying this on the playground. So feel free to contact us over Slack, and we will be more than glad to provide you any additional details as you go through our product. Thanks a lot for your time, and I hope the presentation was useful. There are multiple ways by which you can reach us at Traceable AI, and we look forward to continuous engagement with you over a period of time. Thank you.